This short tutorial is designed to give you a quick overview of creating a bar graph using Excel. The graph we will create is a vertical bar chart with standard error bars. Note that the graph has two dimensions, one a horizontal axis and the other a vertical axis. The height of each column represents the mean at the level of the independent variable, in this case temperature. The bar at the top of the column indicates the standard error in the mean. The top of the column is the mean. This positive standard error indicated by the bar is one standard error higher than the mean, and this part of the bar is one standard error lower than the mean. The narrower this range, the more confidence we have about this estimate of the mean, which is the top of the column. If the study were to be repeated, we would expect the value of the mean to fall within the range of just under 2 standard errors 95% of the time. The standard error is used for statistical comparisons of means. If we simply compare means based on their numeric values, our personal bias will influence our decision. We use the science of statistics to remove our bias in comparing treatments. Normally, we would apply a multiple means comparison test, such as a Tukey's test, and present the results of the test using letter notations. So, for example, this column and this column have the small letter A, and that would indicate that the means do not differ based on whatever test was applied. The third column has a small b, and that is a different letter than the first two, indicating that that mean is significantly different than the first two means. Similarly, the last column has a C, and that would be significantly different than the other three columns. Sometimes the results of a multiple means comparison test may not have been presented in the figure. In the absence of a test, a ballpark estimate to compare means can be made by multiplying the standard error by 3. So, for example, this second bar, the standard error is approximately this long. 3 times that length is approximately in this plane here. So if a mean was below that level, that would indicate that it would be significantly different than this particular treatment. And similarly, you could go the other direction. So this is a rough guide if you don't happen to have a multiple means comparison result in the figure. If you look at the red bars, notice the standard errors for the first, second, and third. If you were to multiply those by 3, they all overlap. And so we could basically conclude that for the other trait, which is represented by the red bar, that those means are not significantly different. In order to create a two-dimensional graph, 3 values are needed for each column. A value for the horizontal axis, this is the independent variable, a value for the vertical axis, which is the mean of the response variable, and a standard error for the mean. Now let's go to an Excel spreadsheet. It is best to arrange the data in a row and column format within the spreadsheet. Set the rows up to be different independent values. The first column, arrange it so that that is the independent variable. The second column is the mean of the dependent variable, and the third column being the standard error, and so forth. This set of data is from an experiment that measured the effect of heat stress on the photosynthetic rate of corn leaves, ZMAs. 4 temperatures were used, 28, 32, 37, and 42 degrees Celsius. Temperature is the independent variable. One of the measured variables, or response variable, is the content of 3-phosphoglycerate, abbreviated as 3-PGA. This is the first 3-carbon molecule formed in the Calvin cycle by the carboxylation of ribulose biphosphate by the enzyme Rubisco. The values of 3-PGA are expressed as micromoles per meter squared of leaf. Those are the values that are presented in the second column. The researchers also measured the content of the enzyme ribisco, and this is in the fourth column. Because this experiment was replicated, a standard error could be calculated for the means of 3-PGA and for the means of ribisco, and these have been presented in the third column for 3-PGA and the fifth column for ribisco. There is heterogeneity of error in this study, which is why the standard errors differ among the means. In this case, the higher the value, the greater is the error associated with the estimate. This row-column arrangement is also how you would arrange the data for more powerful scientific graphing packages such as SigmaPlot. The Microsoft Office package can be used to create graphs, but this program has certain limitations. For example, in the case of trend lines and scatter plots, Excel needs the data to be sorted by the independent variable from low to high. Otherwise, it simply connects the dots based on the orders they are encountered. Other graphing packages such as SigmaPlot do not have that restriction. Now, let's create a bar graph. We'll begin with the means for 3-PGA. Block the cells containing the means. You can use the mouse or the keyboard arrow keys while holding down the Shift key. Now select the Insert tab in the option ribbon. Note that there are a number of chart styles that can be created using Excel. There's columns, lines, pie, bar, area, scattered, and other charts. For this example, we'll create a column chart and select a two-dimensional style. We can now begin to see the chart take shape. A column bar chart is designed to illustrate frequency distributions among classes, but some researchers will also use it to present means of a response variable. Bar charts have the columns equally spaced along the horizontal axis. Note that the default values of the classes, in this case our 4 temperatures, are the values 1 through 4. We'll change that later. A bar chart can have numbers or combination of numbers and text as labels for each of the bars. To replace these values with those from our study, we will use the Select Data button located in the ribbon. In this software program, the first variable is called Series 1. The horizontal labels are the values 1 through 4. To change the value labels, click the Edit key, and then select the cells containing the values we want to use as labels. For this study, we will highlight the temperature values and click the OK button. The values for Series 1 have now been replaced with our temperature values. Click the OK button, and our graph has been updated with the proper values. Now we want to add standard error bars to the values. To do this, we will select the Layout option within the Chart Tools. Note that the ribbon options are different in this tab. We will use the right-hand option called Error Bars. We need to access the extended options, so we will select the More Error Bar option link. I'm going to move this window over so as not to cover the data area. The default settings for a graph are both the positive and negative error bars we presented, and a cap is placed at each end. We could change the colors and styles, but we will stay with the defaults. To enter the standard errors for this study, we need to select the Custom option at the bottom and click the button that says Specify Value. This opens up a window for us to insert the standard errors to display in the positive direction and the standard errors to use in the negative direction. In most analyses, the values will be the same, but there are some analyses in which they will differ. For the positive error value, click on the small toggle to the right and highlight the cells with the standard error and click the small toggle again. Repeat this process for the negative error values. And click OK again to exit the error bar format window. Our graph now has standard error bars. I'll move this graph over just a little bit so I can see all my data columns. For our next step, we will enter the means of the other variable. In this case, it is the content of Rubisco. Under Chart Tools, select the Design tab and then select the Select Data option. On the left side of the frame, there is an Add button. This lets us add additional response variables. Clicking this button lets us add another series. We will give this one a name. We will call it Rubisco. Clicking on the button below this area, we can select the cells that contain the means. And we can click OK, and that takes us back to the previous window. Once again, we can add our axis labels so that they correspond to our temperatures. So we will click the Edit key and then select the range that contains our temperatures. And click OK, and now we have the proper temperature labels to go with our Rubisco means. While we're at it, let's give Series 1 a better name. Click on the series title and select Edit. Enter the name of the dependent variable. So in this case, instead of calling it Series 1, we're going to call it 3-PGA. While I'm at it, I'm going to add some additional information to the graph. I will add the terms plus, minus, SE. Now click OK and OK again to update the chart. Now why did I add the plus minus standard error to the end of this figure legend? The reason is it's a quick way to convey to your reader what the bars represent. And so in this case, those bars will be plus or minus standard error bars. We now need to add the standard error bars for the Rubisco means. Under Chart Tools, choose the Layout tab, and using the drop-down menu on the far right, select More Error Bar Options, select the series being Rubisco, and click OK. And now we can go through the process of adding our specific values for custom error bars exactly the way we did it for 3PGA. And now we have a graph already prepared that has standard error bars for our Rubisco, standard error bars for 3PGA, and our figure legend makes a much better sense than just having Series 1 and Series 2. Now we can add other labels to the graph and improve its appearance. Let's start with the grid lines in the background. These can be distracting in many charts. Under the Layout tab, select Gridlines, select Horizontal, and select the option None. There, that cleans the chart up. If at any time you make a change that you don't want, simply use the Undo button in Excel. That takes you back one step in your changes. To illustrate, I will click the Undo button to take us a step back, and the grid lines have reappeared. I'll select the Redo button to take us forward again. Now let's alter the location of the legend. Because it has been placed to the right, it is compressing the chart. We have lots of room to locate it within the chart. To move it, Under the Layout, choose Legend, and we will do an overlay the legend at the right. So what that does is it places the legend within the chart area and expands the range we have available to us for our bars and our scaling. We can also click on our legend and move it exactly where we would like within this area. So I've just moved it up into that little corner, and it's an area of sort of open real estate. It's not going to cause any problems with interpreting the graph. Our graph needs to include labels for the axes. Under the Layout tab, click the Axis Titles button. And we'll start with modifying the horizontal axis. We will place the title below the axis. In the small little box here, sometimes called the formula bar, we can type in the title we want to use. Since this is temperature in degrees Celsius, we need to give both the name and the units. I'll start by typing the name and a space. Next, I want to insert a degree symbol. I can access symbols by selecting the Insert tab on the ribbon and selecting the symbol option on the far right. I usually like to have my font to be Arial for graphs because they're cleaner, so I usually double confirm that I have Arial as my selected font. And now I can start working my way through the various symbols to find the one that I want. Once you have used this menu a few times, you will see that it builds a list of the most recent symbols you have used. This will save you time in the future. The degree symbol is in the Latin supplement group. I will click it, press Insert, and close the window. Now you'll see that this degree symbol is now in my input line. I'll complete it with a capital C to indicate Celsius and press the Enter key. My horizontal title is now added to the chart. We will now insert a vertical title. We will want to indicate the units micromoles per meter squared because those are the units that our means are expressed in. So in order to insert the vertical title, go back to the Layout, choose Axis Titles. In this case, we're going to do vertical axis. At the end, we're going to want a rotated title, but initially we'll start inserting it as a horizontal title. The first character we have in our title is the Greek letter mu, so we will have to go off to our symbol set. So Insert, Symbol, and go off and find the Greek letter mu. It's in the Greek letter set, but since I have used it recently, I don't have to go hunting. I will just use my shortcut. I'll choose my shortcut, press Insert, close, and now I have my mu symbol in my field. And I'll continue typing the rest of the information. And press Enter, and now our vertical title has now been inserted into our chart. I need to correct the format to proper scientific notation by placing the -2 as a superscript. To do this, I select the title and click within the box. I'll move my arrow key so that the cursor is just to the right of the M. I hold my Shift key down and highlight the next two characters. So the -2 is now selected. To convert this to a superscript, I go to the Home tab on the menu, go to Font. Under the font, there is an option of making superscripts. Click on the box, press OK, and now our title is now in proper scientific notation. Since it is now in the right format, let's rotate the title. So we'll go back to the Layout, choose Axis Title, Vertical Axis Title, and now I'll change it to a rotated title. Notice that our title is now rotated, and so it is taking up less space, and once again the graph is a much larger image. It is possible to edit the titles when they are in the rotated version, but you'll find that it's much easier to edit them in a horizontal plane. Even if you turn your head 90 degrees, it's hard to actually follow exactly what you're doing with your cursor. One last thing I will do is remove the default line around the chart. I will click in an area outside the chart to deselect the chart so you can see the line. Normally, you won't want this. If you review any published paper, this outer box is not included. So click on the chart and do a right click with your mouse. At the very bottom you see Format Chart Area. Choose that option and go to Border Color, change it to No Line, click Close, and the chart has been updated, and if you click out of the area, you'll see that that line has disappeared. And if desired, you can do other alterations to the chart, such as changing the colors, the line styles, and the box fills. Once you are finished, make sure you save your Excel file. To insert the figure into a report in Word or other word processing packages, simply click on the chart and select Copy. Open up your word processor and paste the chart into the desired position. In your Word document, you can resize if needed, add a caption, and position the chart where you want. To do this, click anywhere in the chart, do a right click of your mouse, and you will have a series of options in terms of changing your format, changing the wrapping, inserting a caption, and other possible options for you to modify your document. Now let's go back to our chart in Excel. When one has an independent variable that is a numeric series, it is best to display the means as a scatter plot with connected lines, or a best fit regression line. A bar chart spaces the levels equally and is sometimes hard to visualize a pattern or relationship. In this case, the columns are equally spaced, but the actual temperatures are not. The first two are 4 degrees apart, and the latter two are 5 degrees apart. It's preferable to space the values according to their distance. Since the values of our horizontal axis are numeric, we can easily switch the graph style. Select the Design tab after you've clicked on the chart. Go to Design tab, and on the far left we can choose the option Change Chart Type. That opens up a whole series of options of different types of charts for us to convert the graph to. In this case, we're going to convert it to an XY scatter plot. Don't choose the line option here because the spacing ends up being exactly like you have it for the bar chart. So we'll use the XY scatter plot, and the style we will use is a style that has symbols with straight lines and markers. So we'll click that, click OK. Now we have converted the chart to an XY scatter plot with lines connecting the values. Note the default is the horizontal axis begins at the value 0. We can adjust the styling, so instead of starting at the value of 0, we can choose the range to use. So choose the Layout tab, select Axis, and select Horizontal Axis, and we will go to the More Horizontal Axis options. We'll move this over just a little bit so it's easier to see the menu as well as our graph at the same time. Now we can override the defaults. In our study, our lowest temperature is 28. So let's begin our axis at a little bit below this. So we will start it at, instead of starting it at 0, we will start it at 26 Celsius. Our highest value in the study is 42. So let's stop the axis at 44. We can also change the spacing of the major units. So we'll change the spacing, and so instead of spacing it at every 10 units, which was the default in this particular session, we will change it to be every 2 degrees. And we will also change the minor units to be every 1 degree. And we will add the minor tick marks. The default is none. We will move a minor tick mark to the outside and close. With these changes, we've improved the horizontal axis display and the presentation of our XY scatter plot graph. There are other changes we would want to do to this particular graph, such as changing the size of these symbols so they're not hiding the standard error bars, and we may want to change the colors and the shape of them. For further tips on creating and editing an XY scatterplot graph, see the companion tutorial, Creating Scatterplot Charts in Excel. I hope this tutorial has helped you in creating bar charts using the Excel program.